On problem number 3 on the same worksheet, we're going to do the same steps, but just with the different elements. So the first thing is to figure out what type of reaction this is. Because we have two compounds reacting to form two new compounds, this is going to be a double replacement reaction. So from there, now we're ready to balance. Remember, the first step is to draw a line through your arrow so that you can separate your reactants from your products. Now we're going to count up how many atoms we have for each element in the compound. For carbon, there are 3 atoms. Hydrogen, there are 8. And oxygen, there are 2. Moving over to the product side. We're going to keep the elements in the same order as on the reactant side just so that we can easily compare. And we have 1 carbon, 2 hydrogens, and our oxygen, very important to note here, that our oxygen is in 2 different compounds. So instead of adding 2 plus this 1 here and writing 3, when we write how many oxygens we have, we're going to separate it the way it's written in the formula, 2 and 1. That way we know that oxygen is split up between 2 compounds. Next step, we're just going to start at the top and work our way down. So if you notice, we have 3 carbons on the reactant side and 1 on the product side. So to balance that, we need to put a 3 here. Now that coefficient of 3 is going to get multiplied to not only the carbon, but also to this oxygen, which means that our oxygen is going to change from 2 to 2 times 3, which is 6, giving us right now a total of 7 total oxygens. Okay, so now our carbons are balanced. Our hydrogens are not balanced. We have 8 on the reactant side and 2 on the product side. So if we want 8, what we're going to need to do is put a coefficient of 4 here. That's going to turn our hydrogen into 8 because we're multiplying 2 times 4. And it's also going to change this oxygen here by multiplying it by 4. And so what we've done now is we've taken this oxygen, the one that is just a 1, and we've multiplied it by 4. So that's 4 plus the 6 that we have in the other compound, giving us a grand total of 10 oxygen. So our hydrogens are balanced, and now, last but not least, is our oxygen. We need a grand total of 10. If we look on our reactant side, we only have 2. So very easy, if we want 10, we just put a coefficient of 5 in front of that O2, and that's going to multiply our 2 times 5, giving us a grand total of 10, and now every element in our compound is balanced and the problem is done. If it helps you, you can put a 1 here, but you don't need to. It's implied that if there's nothing there, the coefficient is a 1.